Hello everyone, welcome back to our problem series of NCERT. Now we will cover the remaining problems from chapter 4, which is motion in a plane. Let us look at problem number 4.25. An aircraft is flying at a height of 3400 meters. So this height is 3400 meters. The angle subtended by a ground observation point by the aircraft positions 10 seconds apart is 30 degree. So this entire angle is 30 degree. Therefore, this individual angle would be half of it, which is 15 degrees. What is the speed of the aircraft? So we will have to calculate this distance and then use that to calculate speed of the aircraft. Therefore, if we consider triangle ABC, if we consider triangle ABC, AC is 3400 meters, BC we do not know, but we know angle BAC is 15 degrees. Therefore, tan of 15 degrees can be opposite upon adjacent. So this would be BC upon AC. Therefore, BC will be tan of 15 is 0.2679 multiplied by AC is 3400. So this comes out to be 910.86 meters. So BC is 910.86 meters, but the total distance traveled by the aircraft is twice of BC. So speed is distance traveled by time. Distance is twice of BC divided by time given is 10 seconds. So this would be 2 into 910.86 upon 10. So this would be 2 into 91.086. So this would be 12, 17. So approximately 182.2 meter per second. So speed of the aircraft would be 182.2 meter per second. Now let us move to the additional exercises. Question 4.29. A bullet is fired at an angle 30 degree with the horizontal and hits the ground 3 km away. So we know range is equal to u square sine 2 theta divided by g. We have been given muzzle speed remains same. So u square sine 2 theta. Theta is 30 degree here, so 2 theta will be 60 degree. So u square by g sine 60 is root 3 by 2. Root 3 by 2 is equal to 3 kilometers. Therefore, u square by g is 2 root 3 kilometers, which is 2 into 1.732, which is 3.464 kilometers. And we know u square by g is the maximum range, which is at 45 degree. Now because u square by g, which is maximum range, is less than 5 kilometer, it is not possible to hit a target 5 kilometer away. It is not possible to hit target 5 kilometer away because this is the maximum range, maximum possible range. Let us move to the next question. A fighter plane flying horizontally at an altitude of 1.5 kilometer with speed 720 kilometer per hour. So velocity of fighter plane is 720 kilometer per hour, which is 720 into 5 divided by 18, which comes out to be 200 meter per second. 200 meter per second passes directly over an overhead anti-aircraft gun. What angle from the vertical should the gun be fired for the shell with muzzle speed 600 meter per second. So anti-gun's muzzle speed is 600 meter per second to hit the plane. Now for the anti-gun aircraft's shell to hit the fighter plane, the x component of its velocity should be equal to the velocity of the fighter jet. Okay, so if this angle is theta, x component would be VA sine theta. This should be equal to VF because x component of the velocities should match. Therefore, sine theta would be VF upon VA, which is equal to 200 divided by 600, which is equal to 1 by 3. Therefore, theta will be sine inverse 1 by 3, which is around 19.47 degrees, So this should be the angle at which the anti-aircraft gun should be fired from the vertical. Okay. Now we want to find the minimum altitude that the pilot should fly the plane to avoid being hit. Now first what we will do is we will find the vertical component of the velocity. That should be VA cos theta. Which is 600 into 2√2 by 3. So this would be 400√2 meter per second. So the vertical component would be 400√2. How did I do that? Because cos theta would be under square root 1 minus sine square theta. So that would be 1 minus sine square is 1 by 9. So that would be under square root 8 by 9, which is 2√2 by 3. So vertical component of the muzzle velocity is 400√2 meter per second. The shell will go up and then come down. It will reach a maximum height. So we need to make sure that the plane is flying above that maximum height. So let us find the maximum height reached. So height reached h is nothing but u square upon 2g, where u is the vertical component of the velocity. So that would be 400√2 bracket square upon 2g. So it would be 161234 into 2 upon 2 into 10. So it will be 16,000 meter, which is nothing but 16 kilometer. We have taken g as 10 as specified in the question. So the minimum height at which the pilot should fly the plane to avoid being hit is 16 kilometers. So the pilot should fly at 16 kilometers from the ground to avoid being hit. So then the pilot will be completely safe. Okay, let us move to the next question. Question 4.31. A cyclist is riding with a speed of 27 km per hour. First and foremost, we will convert it into meter per second. So V is 27 km per hour, which is 27 into 5 upon 18. So that comes out to be 7.5 meter per second. Meter per second. As he approaches a circular turn on the road of radius 80 meter. Our radius of road is 80 meter. He applies brakes and reduces his speed at a constant rate of 0.5 meter per second every second. So acceleration is minus 0.5 meter per second square. So acceleration is minus 0.5 meter per second square. We have to find magnitude and direction of the net acceleration. So one acceleration would be in the direction of the velocity, which is always tangential. So if this is the circular turn, velocity would be tangential and first direction would be in opposite to this direction, which would be 0.5 meter per second square, and other would be towards the center, which would be v square by r. Okay, and we have to find the net acceleration. We have to find the net acceleration. So centripetal acceleration AC towards the center is v square by r. So this is 7.5 into 7.5 divided by 80. So this would be 56.25 divided by 80. So this is 5.625 divided by 8. So we get 0.7 8s are 56, 0, 7 3s are 24, 125. So it will be approximately 0.7 meter per second square. So acceleration in this direction is 0.7 meter per second square, and this direction is 0.5 meter per second square. So acceleration's magnitude would be under square root 0.5 square plus 0.7 square. So it is under square root 0.25 plus 0.49. So this would be under square root 0.74. So under square root 0.74 meter per second. That would be the acceleration, the magnitude of the acceleration of the cyclist, which would be at an angle of, so let's say this angle is, theta from the direction of the center. So tan theta is 0.5 upon 0.7, which will be 5 by 7. So angle theta is tan inverse 5 by 7. Angle theta is tan inverse 5 by 7. Okay. So this would be the direction and magnitude of the acceleration. Direction and magnitude of the acceleration. Now let us move to the final question from the additional exercise. Now the last question from the additional exercise 4.32. First part is to show that for a projectile, the angle between velocity and the x-axis as the function of time is given by theta of t is tan inverse v0 in y direction minus gt upon v0 in x direction. Now tan theta would be, what would be tan theta? Tan theta at given time t would be velocity in y direction divided by velocity in x direction. Okay, but velocity in y direction is velocity in y direction at the start, which is v0y minus gt, acceleration multiplied by time, divided by v0x, which does not change. Velocity in the x direction in the projectile motion does not change. Therefore we get theta as a function of time is tan inverse of v0y minus gt upon v0x upon v0x. As simple as that. Straightforward. Nothing else to do. In the second part, we have to show that projection angle theta naught, which is at the start, is equal to tan inverse of 4 hm, which is the maximum height reached divided by range. Now if theta naught is the initial angle, we can write h max to be, what we can write h max to be? U square sine square theta naught upon 2g. U square sine square theta naught upon 2g, and we can write range r as, 2u square sine theta naught cos theta naught upon g. Sine theta naught cos theta naught upon g. Therefore, what we will do is, we will find 4 times hm upon r. So 4 times hm upon r would be 4 multiplied by, hm is u square sine square theta naught upon 2g, multiplied by 1 upon r would be, g will go to the top, 2u square sine theta naught cos theta naught. 2u square sine theta naught cos theta naught. Let us see what all cancels. 2, 2, 4 gone. U square g, u square g, u square g, u square g gone. 1 sine gone with 1 sine. So this comes out to be sine theta naught upon cos theta naught. Sine theta naught upon cos theta naught. Therefore, we get 4hm upon r is equal to tan theta naught. Therefore, we get theta naught is equal to tan inverse of 4hm upon r. 4hm upon r, hence proved. Okay. So now we have completely covered most of the numericals from 4th chapter of NCERT. Let us meet next time with chapter number 5. Thank you.